Hello and welcome. In this video, I'm going to explore the topic of union. I'm going to explain what union is as used in C programming, and I'm going to show you how to use union in C, embedded C programming. Union. A union basically is like a structure or struct, and is used to organize related items of different data types. Basically, what I'm trying to say, this is a user-defined data type, just like struct. And here I have an example of union, and the word union is here. That's a keyword in C, and I have access data, also known as a tag, but remember, as in struct or structure, this is not a variable name. It is a data type, a name of the data type. So here I've created a data type structure or union, and it has, in this particular example, it has two members or elements. Some people call them members, some call them elements. So there are two elements in this union, and the first one is pinned, and is of the type int, which is 16 bits, and the other member is zone, and is of the type unsigned char. So you have they are related to this thing called access data as used in security access system. So that's why you have a pin and you have the zone. Now the members are enclosed within an open curly bracket and close curly bracket, and is terminated by a semicolon. Now the total memory space allocated to the example that we've seen earlier is equal to the member with the largest memory size. I'll come to explain this in a few moments. And all members or elements share the same memory space. All right, so there will be only one memory space, and all the members or elements in that union share the same memory space. And members of a union can only be accessed one at a time. I repeated the union type here, and basically what I'm trying to emphasize here is the variable pin here is of the type int, and it's 16 bits, and it requires 2 bytes. So this pin, this member here is 16 bit, and this member here, zone, which is unsigned char, is only 1 byte, 8 bits. So the biggest memory space occupied by the variable is pin, which is 2 bytes. Therefore, total memory required to store the union variables is 2 bytes. And members can be accessed in any sequence. So you can access the members by using the dot operator. So here we have code.pin assigned 1.123, code.zone assigned with the uppercase A. These are basically, if you have watched my video on struct or structure, you will see that this is almost identical to the struct, except for the keyword. I'll explain the difference later on. Now I have a quote here. It says the above code works fine but will show erroneous output. Now I'll explain this later on. Okay, so I've uploaded the code, demonstration code, into the Tile IDE. So let's take a look at the first 3 lines here. The first one is the include directive to include the header file for the AT89S52 header file, reg52.h. Now the next two header files, inittimer.h and serialprint.h, these are header files that I have written so that to facilitate the printing or outputting data onto the serial terminal. This inittimer.h is to initialize the timer of the AT89S52, and this serial print will print the data onto the serial terminal. So the header files code I have included in the link in the description. So if you wish to try them out, please feel free to download them and try them out. Now, this one here, I'm declaring a union type here. We have discussed this in length earlier, so I'm going to skip this. But I just like to highlight pin, the member of one of the members of this union type is of the type int, so it's 2 bytes. It will require 2 bytes of location, 16 bits. And zone is an unsigned char, 1 byte, 8 bits. So one location, it will require 1 location space in memory. Now in the main function, I declare the union variable using union access data and declare a variable called code, and then I call the init timer to initialize the timer, and then here I want to access the members of the union, so I'm going to use the dot operator. So it's code.pin assign 9355 decimal, and then code.zone assign with the uppercase A, and then I assign code.pin to port 1. That would display the data to port 1, and then here serial print code.zone, that would print the content of code.zone to the serial terminal. So let's go to debug. I've already previously compiled it, so I didn't have any errors. So now before we get into the stinger stepping, just allow me to just highlight something here. Let me zoom in here. So the compiler has allocated 2 memory location, 2 bytes, 16 bits to pin, because pin is of the data type int. So it's 08 hexar and 09 hexar. These are the address of the memory location assigned to pin. Notice zone, the compiler has allocated 08 hexar to zone. This is because if you remember in our early discussion, all members of the of union share the same memory size, so the same memory space. So, and the size of that memory space is the largest, is the member with the largest memory size. So in this case, it's pin. It's got 16 bits, 2 bytes. So the compiler has allocated 2 bytes for this union. So both pin and zone will share the same memory space. All right, so let's zoom out. Let's go to single step. So the first thing is to initialize the timer, because I want to use the serial terminal later. So, and here I'm going to assign 9355 to code.pin. So I'm using the dot operator here to access the pin, which is a member of the union. So that is been assigned with 9355 decimal. Alright, so if I execute that, I also set up the watch window here. So watch out for code.pin in the watch window. Let me zoom in. And we have code.pin with the hex value of 248B. Now 248B is the hex equivalent of 9355 decimal. Alright, so let's zoom out and we go to the next line and we single step. Now zone, code.zone will have hex 41, which is the hex value for the ASCII uppercase A. But also notice that for the upper byte of the pin is also now 41 hex. This is because, remember, all members of the union share the same memory space. So now 41 has now replaced 24 in location 08. Alright, so we will zoom out. Let's zoom out. Okay, and now we will output code.pin to port 1. Notice it's only displaying the lower byte of the pin. This is because pin is a 16-bit 2 bytes data type, but the port here can only display 8 bits, so it only display the lower byte, which is 8B. Alright, from the zone.pin watch window, we know it's 418B. So lower byte is 8B. If you look at the binary, it's 1000, that's 8 in binary, and it's 1011, that's binary for B. And then here we have a serial print. Let us go to the terminal, and we step it, and we get a uppercase A. Now just let me stop the debug and go back in again. Now this time when I like to step it through one more time, but I want to just highlight one point. So we initialize the timer, we allocate 9355 to code.pin. That appears in the watch window. Then and then now we go to the memory window, and we now basically I want to zoom in. Remember, pin has been allocated 08 and 09. So if we go to data memory, you see in 08, 09 we have 248B. Alright, so that's now, let me zoom out. And we go back to watch, so we have 248B, and in memory it's the same thing, but this time we're looking at the actual memory. So it's 248B. Now if I now step it code.zone with cap A and 41 we have, and the upper byte is also replaced by 41. You go to the memory, and we have if we zoom in, we have 41 replacing 24, sorry. So that replaced the upper byte. Okay, so the point I'm trying to make it, we have to be careful when we using union. Is that to remember that all the members of the union type share the same memory, and so as you can see, the effects of that, you can have one member corrupting the data of the other members. All right, so we just have to be aware of this effect. Okay, and so from the demonstration video, we see that the pin, code.pin value is corrupted by the zone value. And we have to remember this is because all the members in the union share the same memory space or locations. Okay, so I'd like to take you back to the code demonstration again to look at in the first demonstration, the way I declare a union variable is I use union access data and then followed by the union variable that I want. Now there is another way of doing this. So if I remove this line of code, let me get it, and then put the union variable up here just after the closing curly brackets of the union declaration, and then save it, and then we clean it, and then we recompile or rebuild. So there's no errors, no warnings, so go to start, stop, debug. And so if I were to cycle through or single step, so we initialize the timer, and then now here we access the members. So it's code.pin. So this one, oh sorry, we'll go to the watch window, which is down here. So we cycle through, we see 248B, and then code.zone assigned with uppercase A, and it's there. So let's do a quick zoom in to check that it's there. Yes, as before. So 24 has been replaced by 41 hexa as expected. So we zoom out. And then now we send code.pin to port 1. And then this one here will serial print code.zone to the serial terminal. And we do get it. And so as we witness, instead of declaring union access data code, semicolon, we put the code, the union variable, just after the closing curly brackets and followed by a semicolon. Okay, so we come to the end of this particular video on unions. And if you like to try out the example that I've shown you, the code and the .h file that I've used in my demonstration, they can be found in the link in the description below. So do try them out if you wish to. And thank you for watching. See you in the next video. Bye.